All right, so welcome again. My name is Matteo, I work for Daniel Wellington, which is the organizer of this meetup. A little bit of the company, we run everything on Amazon, I'd say 100%. And this is more or less our footprint on the major AWS services with the goal to move more and more away from the traditional EC2 service towards Docker containers and serverless microservices. What about me? I work for the cloud operation team. We take care of keeping the cloud infrastructure up and running. We take care of supporting the developers. We take care of scalability, reliability. We keep an eye on costs. And we build a lot of stuff on top of Docker and serverless when we can. And our favorite dev language is probably Go, but I will mention no. So let's keep my manager is happy. So what about this talk? We are gonna talk a little bit about spot instances, which is, you might know, is the spare capacity that AWS offer at discount price compared to the on-demand. Sometimes you can reach 90% off. But average, I'd say, like is 60–70% of the on-demand price. And we're not gonna do any particular introduction about this technology, but more what's our experience into moving some of our workload into using spot instances. So everything started as a summer project. And we focused on moving one of our ECS, or a couple of our ECS clusters actually, from on-demand to spot. It looked at the beginning really simple. It's just a matter of basically changing one parameter in the auto-scaling group, and you redeploy your CloudFormation stack, and that's pretty much it. You get your ECS cluster sitting on top of spot instances. But this brings a couple of cover or issues or whatever you want to see them. We'll see them about in a bit. So the reason is obviously we could reduce the cost. So if we can save 70–90% of our cost in our infrastructure, why not? The business will be happy. But also it meant for us improving the best practice on how we consider reliability and redundancy on our stacks and our deployment. Given the fact that everything might fail, you would think on how you deploy your application in a kind of a different way. So more towards embracing failures rather than just waiting for them and fix them on the go. This is a little bit overlapping with some concept from the chaos engineering, if you wanna see it like that. So the focus is more on how the software is written, how the software is deployed, rather than where it is deployed. So the type of application we target at first, obviously, were production application or application that would impact the business. You don't wanna do that. So CI/CD tools were a good option, chatbot, all the dashboards we use for monitoring and so forth. And as I said before, with spot instances, you basically face a couple of issues. One of these is termination. So according to Amazon's latest reinvent, it seems that from their statistics, 95% of the spot instances are actually terminated by the end users. But you still want to cover for that 5% of instances that might go away at any time, because Amazon is going to reclaim capacity. So what Amazon provides is a 2 minutes event when before the actual instance interruption. And 2 minutes is quite a lot of time to do a couple of things and shut down the system basically. So you get a CloudWatch event, which is always great because you can use it with serverless, for example, which is what we did. So you have a EC2 spot instance interruption warning 2 minutes before, and then you can fire. You can tie an event to this CloudWatch event. And in the specific case, we wrote a lambda function that send a draining state to the ECS instance. Draining state means that all the containers that are deployed on the instance get SIGDAR. All the target groups where the containers are registered are drained. And then the scheduler will get an event, and you will instantiate the container on the active nodes. So this was the kind of the first thing we had to care about if we didn't want to kind of lose capacity out of the blue and then get an instant terminated and maybe container being terminated not in a nice way. And then after that, your autoscaling group will be missing one host, and it will try to get capacity back, and you will have your happy ECS cluster back. The problem is your containers are deployed, or your tasks deployed on this ECS cluster won't be balanced, because the ECS doesn't have a way, native way to rebalance the workload once an ECS instance gets removed and added. But CloudWatch events are great, and they come really helpful if you can take advantage of that. And you have this ECS container instance state change. So when an instance comes back and is active in the ECS cluster, you would get this information in some way. And like the termination event, you can take advantage and write a lambda function to take some actions. So we have kind of a small demo of this working. So you can see we have an ECS cluster running 2 services and 4 tasks per service. And they are distributed evenly among 2 ECS instances. So if now we simulate a way to start, for example, a way to add capacity to this cluster. So we have 2 more ECS hosts. we have to wait a bit. So basically we are adding new ECS hosts to the auto-scaling group. We add capacity, and given that these services are, now is it the service level or, let's see, I can't remember. I can't remember if it's in a service level or task level, that you basically can say, spread my tasks or by EAZ, so availability zone, and by ECS instance, which means that the scheduler will try, once we trigger an event, the scheduler will try to propagate these tasks evenly on these on the ECS instances. It's going to take a while. Yeah. Oh, that. So one is coming in. Yeah, one of these tasks is the commission from one of the instances, or two of them. Yeah, so you should end up with two to learn two of each service. In the background is there's a lambda function that gets triggered on the ECS instance event, and what this lambda function is using the SDK to trigger a deployment of the service, or redeployment of the service with the same task definition and everything. So it's almost like an empty deployment, but this will trigger the rebalance of the cluster and reconsidering all the placement rules that are tied to the service. Depending on the deployment strategy, so you will see either it's going to increase the capacity if you have, like, for example, 100% capacity and 200 max capacity. So it will increase the nodes before shutting them down. So there's not gonna be any downtime in this rebalance. Yeah. It's not sit there and look at it. So how would you like? We would like to see going forward. Obviously, we would like to move more workload. If we find more test environments and maybe production environment, why not? If we find, for example, environments that don't need to be up and running all the time and can accept downtime or a reduced capacity for a small period of time. And the other option is, so the 14th of November, AWS launched the possibility to create mixed auto-scaling groups. So you can have a baseline capacity with on-demand, and then you can scale up to extra capacity with spot instances, and you can create a mixed auto-scaling group this way, which is great, I think. So the code base for both the lambda functions is available on our GitHub repo if you want to look. It's written in Go. Yeah. That's the most important part. Cool. Anybody else? Questions or?
You show the lambda function and then do that.
Do you want to see it?
Yeah. Show the code.
How often do you get these eviction events?
Sorry?
How often do you get these eviction events? Evictions?
We haven't seen them in ages. Like, it's more often than we rebuild the cluster because Amazon releases a new MI or because we change the launch configuration or things like that. Then we see nodes being reclaimed from Amazon.
There is a third-party service called Spottings. Do you evaluate that?
No, we haven't seen that. We haven't looked into that. But the good thing of Spottings is that they actually promise a 15 minutes, I think, termination event. I think they have some sort of machine learning running in the background, so they know, for some reason, they know before AWS, when AWS goes down. You see it? How do you see it? No, that's hard. I don't think it fits. I can explore whenever you want.
I have a question. In one
Yeah.
of your slides you mentioned that once the instance goes down or is reclaimed, you get that cloud vouch sort of event, and then it could be that the rebalancing is not done correctly.
Yeah, exactly. When the auto-scanning group gets back to his target.
How did you solve that?
That's the lambda function that we...
Okay.
Yeah, so we get the event, the lambda function would get the event, and then it would trigger an update for each service that is running on that TCS cluster.
That is something that we will have to figure ourselves.
Yeah, but you have to you have to build your own logic there, which is, I don't know. At first you would think, okay, why AWS? Amazon doesn't think about these things, but then I don't know. You have all these Lego pieces that you can fit together, and you get your solution. I think is fairly good.